Topic 1.5, Humans and Pollution. So we've learned how to model a system, and we've discussed the idea of what sustainability is so that we don't have a depletion of any of the storages. Unfortunately, one of the ways we deplete storages is by converting a lot of our useful resources into resources, pollution, which are waste, which are not useful, and that depletes the system. So we could think about pollution really as being a disturbance. It's something which makes your cycle unsustainable. We can see in particular over here, we have solid domestic waste pollution, which is really destroying this beach coastal area. There are three different strategies we could have to deal with it. We call them tiers. Tier 1, simply take a bad behavior and try and replace it with one which is less harmful. For example, today is actually trash pickup day in my neighborhood, and I separate my trash into traditional garbage and to material which will be recyclable. So I'm trying to break an old habit, replace it with a better one. Tier number 2 is reduction, mitigation, basically. So we could have technologies that could limit emissions, smokestack scrubbers on factories, for example, that would prevent the release of carbon dioxide and sulfur dioxide into the air. We could have legislation to try and reduce pollution also. And tier number 3, which is the most difficult one, is trying to restore damaged areas. So the Environmental Protection Agency, formed in the 1970s, the EPA, their purpose was basically to identify hazardous waste sites around the country and try and clean them up. I can't remember what percentage they've been effective on, but it's been pretty small. It just takes an enormous amount of money, time, resources to do something like that. So let's just see if we can define what pollution actually is. What are the categories? Well, it could be organic or inorganic. And it doesn't have to be something which is non-living. It could be something living too. So an invasive species, for example, is an organic form of pollution. Inorganic, plastics. So microplastics out in the ocean is becoming a big problem these days for marine wildlife. Could be primary or secondary. Primary means you can find the source of where it comes from. It's active right away. So sulfur from burning coal or sulfur dioxide coming directly out of the tailpipe of your car. Secondary means there was another reaction which took place, which made it into something new. So for example, acid rain would be a great form of secondary pollution. You have primary pollutants coming out of the tailpipe of your car, mixes with water in the air. Nitrous oxide, for example, mixes with water to make nitric acid. Sulfur dioxide mixes with water to make sulfuric acid. Those would be secondary. So secondary means there was a transformation that took place. Point or non-point. Point means you can absolutely locate the point of origin. For example, nuclear waste from the meltdown in the Chernobyl, Ukraine nuclear power plant. Non-point means it's been dispersed. So again, acid rain would be a great example of non-point pollution. The effects could be acute or chronic. Acute means short-term, asthma attack. Chronic means long-term, lung cancer from exposure to asbestos, for example. It could biodegrade or not be biodegradable. So if we know it biodegrades, we're lucky. We can just leave it alone. It'll go away over time. Acid rain probably is like that. If it's persistent, though, it can't be broken down. A lot of artificial chemicals are persistent, can't be broken down. For example, DDT, we'll talk about that at the end here. Most modern pesticides, though, that we use these days are biodegradable. They can be broken down. And so I think that another example is the replacement of laundry detergents into biodegradable ones. Now, the buildup, we've talked about the depletion of pollution of resources in the form of pollution. One of the things which exacerbates the problem is something we call biomagnification. So it works like this. Living things take in various types of pollution, but since living things live for a long time, they can magnify. So let me give you a couple of examples. How about mercury in fish? Let us suppose that the Willamette River nearby has a certain concentration of mercury in there, which makes it dangerous. But it's a fairly low level, shall we say. But fish, which live in the river, they drink that water continually, and that mercury then gets incorporated into their bones. And as they drink more and more year after year, they accumulate more and more mercury. I mean, it's persistent. It doesn't go away. When you then go to a restaurant and you order a nice fish, and they bring it to you, the concentration of mercury in that fish could be many, many times higher than the concentration of mercury that was originally in the river water because it has accumulated biomagnification over time. Same thing happens with DDT. This was a pesticide that we sprayed to eliminate various insects and pests. But when it gets into birds, it accumulates, and over time, the concentration gets higher and higher. And then when you go to a restaurant or the supermarket and you order a nice chicken or whatever, it could have a very, very high concentration of DDT in it because it has accumulated over time. DDT was recognized as being a problem in biomagnification. It originally was thought to be a real panacea for eliminating diseases, but we realized later on that it bioaccumulates in living things and becomes harmful to us, and now DDT has been banned. It is made illegal.